Have you ever stopped to listen to the buzzing sound emitted by an electrical line as it passes overhead? It's a peculiar sound, isn't it? We often hear it while walking down the street or when we're near a power line. On many occasions, this sound blends with the everyday noise of the city or countryside, and it's easy to overlook. But if you've stopped to think about it, you may have wondered, why do these lines, which seem so simple and static, make such a strange sound? That buzzing you hear while walking down the street or when you're near those massive electrical transmission towers isn't random or a result of some system failure. In fact, although the buzzing might seem like an insignificant detail or something trivial, it is actually the result of a fascinating and complex physical phenomenon involving electricity, heat, and material physics. In other words, behind that simple sound lies a principle of nature that allows our cities and homes to be illuminated and connected through electricity. We're likely not paying much attention to it, but this buzzing has a story behind it. To understand why it happens, we need to dive into a phenomenon called electrical corona. And this is where things get interesting because what happens is much more surprising than you might imagine. This phenomenon occurs when electricity flows through high-voltage wires, cables that are so powerful that they generate very strong electric fields that affect the air around them. Imagine you're under a high-voltage power line and start hearing that characteristic buzzing. The first thing to know is that it's not a mysterious or harmless sound for no reason. What you're actually hearing is an electric discharge. But don't worry, we're not talking about a lightning bolt or a current as dangerous as one that could fall from the sky. This buzzing is caused by small electric discharges that occur when high-voltage wires become saturated with elevated voltages. And these small discharges are what generate the sound. The sound is a result of ionization of the air, and this in turn causes that constant buzzing. To put it in perspective, the power lines that carry high-voltage electricity, like the ones on large transmission towers, have very high electrical potential. These lines carry thousands of volts, and as the electricity moves through these cables, the electric field they generate can become so strong that it affects the air around it and even changes it physically. This electric field can be strong enough to ionize the air around the cables. So what does ionizing the air mean? Well, air in its natural state is neutral. It has no electrical charge. But when the electric field around a conductor, a cable in this case, is strong enough, the air starts behaving like an electrical conductor. This ionization process makes the air molecules become charged, releasing electrons that move quickly. As a result, the air becomes a conductor of electricity for a brief moment, generating small sparks or discharges between the cable and the air molecules. It is this excitation of the air particles that produces the characteristic buzzing. If you get closer to the line, the sound will be more noticeable because the air is literally vibrating due to the small electrical discharges. Even though we can't see it, this phenomenon is constantly happening around high-voltage cables. The most amazing part of all of this is that we're not always aware of what's happening around us. Although the buzzing is audible to us, electricity travels so fast that the physical effects on the air happen in fractions of a second. The electrical energy is flowing through the cables at a dizzying speed, but the ionization of the air is something we don't see with the naked eye. What we perceive as a simple buzzing sound is, in reality, the result of these phenomena occurring in the air, invisible to the human eye. So, if you've ever wondered why some power lines buzz louder than others, the answer has to do with two key factors: the voltage of the electricity they carry and the design of the cables. As voltage increases, the electric field around the cable also intensifies, and since the ionization of air depends on the strength of this electric field, lines carrying higher voltages are more likely to produce the buzzing we hear. If you've ever seen a high-voltage transmission line like those that span long distances in rural areas, you've probably noticed that the buzzing is much more pronounced compared to the low-voltage power lines you see in city neighborhoods. The reason is simple. High-voltage cables carry much more voltage, so they generate a much stronger electric field. This makes the air around them more likely to ionize, which intensifies the corona phenomenon and therefore makes the buzzing more audible. But that's not all. The electrical corona phenomenon doesn't just generate that buzzing. It also impacts the efficiency of energy transmission. When ionization occurs in the air, a small amount of electricity is lost in the form of heat. This heat doesn't go to the final destination of the electrical energy, whether it's a city or a factory, meaning that some of the electricity being transported doesn't reach its destination efficiently. Although this energy loss is small, it is significant when considered on a large scale. And because of this, electrical corona can also indicate that the line isn't functioning at maximum efficiency. Engineers who design electrical grids must take this phenomenon into account when building transmission lines. The design of the cables, the type of insulation, and how electricity is distributed along the lines all influence the amount of ionization that occurs and how much energy is lost due to the electrical corona. This is why high-voltage transmission lines are often equipped with special insulators and structures that minimize ionization of the air, preventing this energy loss from becoming greater. In summary, the buzzing you hear is much more than a simple sound. It is a physical manifestation of the interaction between electricity, the air, and the electric field created by high-voltage cables. And although we're not always aware of what's happening around us, this small discharge of energy is a reminder of how impressive the invisible world of electricity can be. Now you may be wondering, is this buzzing dangerous? Fortunately, the answer is no. The sound you hear when passing near a power line is not something you should fear. In reality, it's just a manifestation of the physical process that occurs when electricity travels through transmission lines. It's not an indicator that something is wrong with the power line, nor does it represent an immediate danger to people in the area. This buzzing is indeed completely harmless in terms of safety. However, that doesn't mean it's entirely irrelevant from an electrical engineering perspective. While the buzzing is not dangerous to the people who hear it, there are situations where it can become more pronounced and can be an inconvenience or a sign that atmospheric conditions are altering the functioning of the power line. For example, when atmospheric conditions favor ionization of the air, something that happens especially in areas with high humidity or on rainy days, the electrical corona phenomenon can become more noticeable. Humidity in the air plays a crucial role in this, because water in the form of vapor in the environment can help conduct electricity more effectively. In these cases, the small water particles in the air allow electricity to move through it more easily, intensifying the ionization process, and as a result, amplifying the buzzing. When humidity is high, transmission lines can experience more energy losses, and the buzzing can also become louder and even more constant. So, if you've ever wondered why sometimes the buzzing is more sharp or annoying on certain days, humidity has a lot to do with that. But what else influences this phenomenon? What's interesting is that not only humidity and atmospheric conditions affect the buzzing, but also the shape and design of the cables. Power lines aren't just thick cables hanging from poles randomly. They are carefully designed to minimize energy losses and maintain a steady, efficient flow of electricity, reducing the chance of unnecessary discharges through the air and improving the overall performance of the energy transmission system. Electrical engineers spend a lot of time and effort designing these lines, making sure that the cables are as efficient as possible. One of the most important aspects of these cables is the geometry of the conductors. Depending on how they are built, some cables allow for a more even distribution of the electric field. This in turn helps minimize ionization of the air around them, which not only reduces the buzzing but also the energy losses. If you've ever had the chance to closely observe a power line, you've probably noticed that the cables are often covered with an insulating layer. This insulation serves a very important purpose: to prevent electricity from escaping through the air. The insulating layer is designed to prevent energy from dissipating uncontrollably and creating additional discharges. This not only helps reduce the buzzing but also contributes to maintaining the energy efficiency of the system, ensuring that more energy reaches its destination without being lost as heat or unwanted discharges. Additionally, some transmission lines are equipped with specialized devices that allow the electric field to be distributed more evenly along the conductor. This reduces the intensity of air ionization and, as a result, minimizes the amount of sound generated by the electrical corona phenomenon. Therefore, although the buzzing may seem simple, it's deeply connected to the engineering that ensures electricity travels safely and efficiently from power plants to the homes and businesses that depend on it. Every detail in the design of these lines has a purpose, from the type of insulation to the arrangement of the cables and the electric field control devices. Now you may be wondering what happens when power lines are not suspended in the air. In many urban areas, power lines are installed underground. This might surprise you, but the buzzing disappears completely in this type of installation. The reason is quite simple. When the lines are underground, there is no air to ionize around the cables. Underground lines are surrounded by earth, which eliminates the electric field that interacts with air molecules, and therefore the electrical corona phenomenon can't occur. In this type of underground installation, electricity flows much more silently and efficiently without the interference generated by aerial lines. This also has its advantages because not only is the buzzing eliminated, but there's also a lower chance that the lines will be affected by extreme weather conditions like windstorms, rain, or snow, which could damage overhead lines and cause power outages. Therefore, underground lines are generally more stable and less prone to generating issues in the electrical supply, although they are also typically more expensive to install and maintain. So, the next time you pass under an underground line, you can enjoy complete silence without the buzzing characteristic of overhead lines. And if you find yourself near a high-voltage overhead line and hear that familiar buzzing, now you know what causes it. It's a fascinating manifestation of how electricity interacts with the air around us, and a clear example of how engineering and physics intertwine in every corner of our daily lives. The meticulous design of power lines and transmission systems demonstrates how technology can leverage the laws of physics to transmit energy efficiently and safely, and all of this is happening constantly, often without us being aware of it. Would you like to learn more about how electricity affects other things in our daily lives? Or do you have any other scientific curiosity you'd like to explore? Let me know in the comments, and if you enjoyed this content, don't forget to like and subscribe for more. See you next time.